Hello, students. Okay, I promised you a video about using the KB equation to get our pH. And I told you it's very similar to Ka, but it's for a base, so it is a little bit different. So I'm going to go through an example for you here. We've got a 0.15 molar solution of NH3. And we want to know, they've asked us, what are the equilibrium concentrations of everything? And they want to know what's the pH. Okay, and they told us our Kb is 1.8 times 10 to the minus 5. So that's good. We've got something good to work with. Now, what we're going to do is the same thing we did with our weak acid. We're going to say this is a weak base. What does it do? It reacts with water and forms the conjugate acid and OH minus. That's the Kb reaction. So I'm going to write that reaction out. NH3 plus water. Because it's a base, it's going to be accepting a proton. So we get NH4 plus and OH minus. And what we're going to do is we're going to put in our initial concentrations. The only one we know is 0.15 molar for NH3. They didn't tell us anything about these, so we're going to call them 0. We're going to lose a little bit of this. We're going to gain a little bit of these. And at equilibrium, we have 0.15 minus X, X, and X. Okay, so now I'm thinking I need to use my KB. So I'm going to write my expression for KB first. Always write the expression. I know it's annoying. I know it takes time, but it's going to save your bacon somewhere. You're going to be glad you did it. Okay, so we put in our NH3 at the bottom. That's our expression. We plug everything in. We've got x squared over 0.15 minus x. This equals 1.8 times 10 to the minus 5. That's our KB. We're going to neglect x here because 0.15 is 3 orders of magnitude larger than 1.8 times 10 to the minus 5. So it's okay for us to neglect x here in the bottom. And we can solve for x equals 0.0016. This is equal to our concentration of OH minus, and it's equal to our concentration of NH4 plus. And we can find our concentration of NH3 with sig figs. It's still about the same, 0.15. When we subtract 0.0016, we get basically the same thing. So our small x approximation was valid. So now we've got all of our equilibrium concentrations, but we have to find the pH. That's the last thing. We have the OH minus concentration, so we can get the POH, the negative log of 0.0016. So our POH is going to be 2.79, and our pH will be 14 minus that, which is 11.21. So we've got our pH, we have our equilibrium concentrations here and here, and we've solved our problem. So what are the things that are important to remember when you're doing this problem? First thing, you need to know what the reaction is that's happening. This is a weak base. When you put it in water, it reacts with the water. It makes the conjugate acid and OH minus. That's what weak bases do. So when you see a weak base, that's what you should think about, that Kb reaction, just like we wrote here. This is our Kb reaction that we wrote in our rice table. I can't get the pencil to work here. That's our Kb reaction, okay? The exact reaction, base plus water makes conjugate acid plus OH minus. Second thing, this is different than when you use the Ka. When you use the Kb, the thing you're making on the other side is your conjugate acid, and you make OH minus instead of H3O plus. Now, of course, that makes sense because it's a base, so it's going to make OH minus and not H plus, right? But that's a place where you can trip up, because when you've got the OH minus, you might just take the negative log of it and think you're done, right? So you always want to check at the end. Like here, I got my POH and it was 2.79. That wouldn't make sense as a pH because I'm talking about a base and it's a basic solution. So it should be above 7. So if I got 2.79, I should check myself and make sure that that makes sense. Okay, good. Last couple of things. make sure you write out your expression for your KB. I know you don't want to do it, but there will be a time when you'll make a mistake because you didn't write out the expression, and then you'll see why I tell you to do it. So just do it. It's a good practice always. Anytime you're dealing with an equilibrium constant of any kind, always write out the expression first and then plug in your values from your Rice table. So that is our summary of how you do this problem with a KB and finding the pH of a solution of a weak base. I hope that's helpful and that you have a great day.